podcast. Today we're going to for I like to move it. Transformations of exponential and logarithmic functions. Warm up. Determine the inverse of each function, which we're going to do on this part of the page. Okay, first step on the inverse, change f of x to y. So y equals 2 to the x. Next step, change x and y. So x equals 2 to the y. Okay, and then we're going to take log base 2 of both sides. Log base 2 of 2 cancels, so you're left with log base 2 of x equals y. So f inverse of x equals log base 2 of x. All right, go ahead and finish up number 1. All right, number 2. First step, change g of x to y. So y equals log base 4 of x. Then switch the x and y. So x equals log base 4 of y. We're going to raise both sides by 4. So we have 4 to the x. 4 to log base 4 cancels, equals y. So g inverse of x equals 4 to the x. Let's take a look at 3. Okay, first step, change h of x to y. So y equals 7 to the x. Switch x and y. So x equals 7 to the y. And then we're going to take log base 7 of both sides. Log base 7 of 7 cancels. So you're left with log base 7 of x equals y. So h inverse of x equals log base 7 of x. Well, last one, let's take a look at 4. So first step, change k of x to y. And then switch x and y. So x equals log base 10 of y. Then we're going to raise both sides by 10. So you get 10 to the x. This cancels, equals y. So k inverse of x equals 10 to the x. All right, go ahead and finish up the warm-up. All right, let's take a look at the next page. Getting started. Don't flip out. Consider the two tables that show 4 exponential functions represented as equations and as graphs. Analyze the graphs, match each exponential equation to its corresponding graph, and write the equation under the graph it represents. Write an equation for each function g of x, h of x, and j of x in terms of f of x. Describe each transformation. Okay, so A is h of x equals negative 10 to the x. The transformation is reflect over the x-axis. B is f of x equals 10 to the x. C is j of x equals negative 10 to the negative x. It reflects x-axis, reflects y-axis. And D is g of x equals 10 to the negative x, and that reflects the y-axis. Okay, go ahead and complete that. All right, let's take a look at the next page. Go ahead and mark out 2 and 3. Consider two tables that show 4 logarithmic functions represented as equations and as graphs. A is j of x equals negative log base 2 of negative x, and that reflects the x-axis, reflects the y-axis. B is f of x equals log base 2 of x, C is g of x equals negative log base 2 of x, and that reflects the x-axis. D is h of x equals log base 2 of negative x, and that reflects the y-axis. All right, go ahead and finish up that table. All right, go ahead and mark out this page. 4.1, graphing transformations. In the Getting Started, you analyze transformations of exponential and logarithmic functions that were a reflection across either x-axis or reflection across both axes. You know that transformation performed on any function f of x to form a new function g of x can be described by the transformation function g of x equals a times f of b of x minus c plus d. 1. Consider each transformation to f of x equals 2 to the x. Describe the effects of each transformation, then sketch the transformation graph. The transformation is vertical dilation by a factor of 5, and this is this corresponding graph right here. All right, go ahead and finish up number 1. B. P of x equals 2 to the x minus 4 is right 4 units, and it's this graph right here. C. K of x equals 2 to the x minus 3 is down 3 units, and it corresponds to this graph right here. All right, go ahead and finish it up. All right, let's take a look at the next page. 2. Consider the transformations to f of x equals 10 to the x. Describe the effects of the multiple transformations. Then sketch the transformed graph. A. S of x equals negative 3 times 10 to the x plus 2 minus 1, which reflects the x-axis, left 2 units and down 1 unit. That corresponds to this graph right here. B. T of x equals 2 times 10 to the x minus 1 plus 3. That's a vertical stretch by a factor of 2, right 1 unit, up 3 units. And that graph corresponds to this graph right here. All right, go ahead and finish it up. All right, let's take a look at the next page. The student works 4A, 4B, and 4C. The student works 5A and 5B. Okay. 4.2, describing transformations. You can describe a transformation in more than one way. In terms of the original function as an equation of transformed function form, using key characteristics or using words, it is possible to describe the same transformation using different notation. 1. Inaz and Topher describe the effects of transforming the graph of f of x equals 3 to the x, such that p of x equals 3 times f of x. Who is correct? Explain your reasoning. Both Naz and Topher are correct. All right, let's take a look at the next page. Two, analyze the graphs of f of x and g of x. Describe the transformations performed on f of x to create g of x. Then write an equation for the g of x in terms of f of x. For each set of points shown on f of x, the corresponding points are shown on g of x. A. G of x equals negative f of x minus 2. It reflects the x-axis and is right 2 units. And it corresponds to this graph right here. B. G of x equals 2 times f of x minus 3. That's a vertical stretch by a factor of 2 and down 3 units. Okay. C. G of x equals f of parentheses x plus 5, and that's left 5 units. D. G of x equals 4 times f of x. That's a vertical stretch by a factor of 4. Okay. Go ahead and finish it up. Three. The equation for an exponential function m of x is given. The equation for the transform function t of x in terms of m of x is also given. Describe the graphical transformation on m of x and produces t of x, then write an exponential equation. A. M of x equals 2 to the x. T of x equals 0.5 parentheses m to the x plus 3, which is equal to 0.5 times 2 to the x plus 3. That's a vertical compression by a factor of 0.5 and left 3 units. B. M of x equals e to the x. T of x equals negative m of x minus 1, which equals negative e to the x minus 1, which reflects the x-axis and is down 1 unit. C. M of x equals 6 to the x. T of x equals 2 times m of negative x, which equals 2 times 6 to the negative x. And it's a vertical stretch by a factor of 2, and it reflects the y-axis. 4. The equation for a logarithmic function m of x is given. The equation for the transform function t of x in terms of m of x is also given. Describe the graphical transformation on m of x that produces t of x, then write a logarithmic equation for t of x. A. M of x equals log of x. T of x equals 3 times m of x plus 4. So that's equal to 3 times log of x plus 4. That's a vertical stretch by a factor of 3 and up 4 units. B. M of x equals ln of x. T of x equals m parentheses negative x minus 1, which equals ln of negative x minus 1. That reflects the y-axis down 1 unit. C. M of x equals log base 2 of x. T of x equals 0.2 m x minus 3. So that's 0.2 log base 2 of x minus 3. That's a vertical compression by a factor of 0.2 and write 3 units. All right, go and finish it up. Go ahead and mark out this page. Finish up your notes, start working on the assignment, and have a wonderful Wildcat day.